Hi friends, I will be teaching signals and systems for you. So before going into the subjects, let's just start with a real life example where we are using the concept of signals and system. This picture denotes the block diagram of microphone and loudspeaker system, okay, where the voice is fed to the microphone. Microphone has the ability to convert this voice signal into electrical signal. This electrical signal will in turn fed to the amplifier, which will increase the amplitude of the signal. The amplified signal now will fed to the loudspeaker, which will convert the electrical signal into again voice signal. So if you see in the whole process, so voice is fed to the microphone. Voice is a kind of signal which is fed to the microphone, and it is producing another kind of a signal called electrical signal. So microphone is a system which can take voice as input and produces electrical signal as an output. So in this example, microphone and amplifier and speaker are examples of system, and voice and electrical signal are examples of signals. Now we will discuss what is the formal definition of the signal. Signal is a function of one or more independent variables, and it will also has certain information associated with it. Okay, in the previous example what we have seen, voice is a signal. So voice will contain certain information inside it, and the amplitude of the voice is varying with respect to the time. So the graphical representation of these signals will be something like this. So I will represent, this will be a time axis, and I will represent here amplitude of the voice signal, which will be denoted by x of t. So the amplitude of the signal is varying. Okay, so any signal which is varying will contain certain information with it. Now other examples of signal are electrical signal, electric field, and what else, telephone signals, those are nothing but EM waves. Even light is also an example of signal because it will have certain information with it. Like when you are driving a car, if you see red light, you will stop the car. So that means you are able to receive some information from the light. So light is also a kind of signal. Now let's discuss what is a system. Okay, system is a physical entity which has the ability to take signal as input and do certain manipulations on that and produces other signal as output. If you see example of the system is the previous we have seen microphone. So microphone will take voice as input and produces electrical signal as output. And other examples are, take an example of phone, which will take wireless signal, that is nothing but EM, electromagnetic wave, as input and produces some image or ringtone. That means sound as an output. So other examples of a system is or nothing but aircraft landing system, aircraft landing system. So now I'll represent the block diagram of the system. If you see, system will take some input which is denoted by x of t, is a signal, okay, and which will produce some output after certain manipulations. So that is nothing but y of t. So the mathematical model of the system is denoted by h of t. Throughout this course, the system function will be denoted by h, whether it is time domain and frequency domain and any other domain. So now we understood what is system and what is signal. Okay. If you take x of t here, it is a signal, but sometimes this x of t is very complex to analyze. Then it is very difficult to find the output of the signal for that input. Okay. Now what we have to do is we have to represent x of t in terms of some basic functions. So the basic functions are nothing but sine, cos, unit step, impulse. So all these are basic functions. So now our aim is to represent x of t in terms of all these basic functions. Okay, plus so on. So now we want to represent this x of t in terms of all these basic functions. But there is a similar concept which is available in the vectors called component of a vector. Component of vector. So now we are moving to read this subject, components of vector. So based on this, we'll find out the values of a1 and a2. Because the reason for going into the vectors is we are very familiar with the vectors. Okay. What is a vector? A vector is a quantity which has magnitude and direction. Magnitude and direction. Okay. So the examples of vector are nothing but force, electric field, magnetic field. Okay. So I'll take a two-dimensional coordinate system where I'll represent the point x comma y vector. So this is x-axis, this is y-axis. Now this is a point 2 comma 3. So if I draw a line from origin to this point, this is a vector. Okay, the point will be denoted by a, and this is a vector denoted by a bar. Okay. So now in two-dimensional coordinate system, the unit vector along the x direction is vx and the unit vector along y direction is vy. So now a bar is equals to 2 into vx plus 3 into vy. This is the representation of the vector in the two-dimensional coordinate system. Again take two-dimensional coordinate system. Okay. So A and B are two vectors. Now I want to represent B in terms of A. So B bar equals to C into A bar. Okay, like in this form I want to represent. But there is always some error associated with in this representation which is denoted by E bar. So if you take C into A bar, maybe something like this. C into A bar and E bar will be something like this. So when we add these two will get B. But there are some possibilities for the direction of E bar. So now I will draw those possible cases. Okay. So now the vector this is B. I want to represent this is in terms of A. So I can represent something like this. My C1 it is C1 A1. It will be till here, and the error vector can be something like this. Okay. Similarly, I have the vector B and A. I want to represent something like C2 A and E2. Okay. The other possibility is something like this. This is B, this is A, then something like C3 A and E3. Now if you see E3 will be exactly perpendicular to A. So now I want to represent B in terms of A. So there is always some error associated with it. But my aim is to find the value of C in such a way that to minimize this error. You see here when E3 and A are perpendicular to each other, then the error will be minimum. So for this case, to find C, E3 should be perpendicular to A. Okay. So now this will form a right angle triangle. If you see CA, E and B will form a right angle triangle. So from this I can find the value of CA. So I am taking the magnitude. So CA is equals to, magnitude I am taking is equals to, so the component of vector B along the direction of A is nothing but B cos theta. You can find simply by using the right angle triangle equation. So this is also magnitude. Okay. Now I'll multiply both sides with mod A. Now this will be equals to A bar dot B bar. So C equals to A bar dot B bar by mod A square. So mod A square can also written as A bar dot A bar. Okay. So now the component of a vector B along A is denoted by C into A, where C equals to A bar dot B bar by mod A bar dot B bar mod A and mod A, or A bar dot A bar I can say. A bar dot A bar dot A bar. But when A bar is perpendicular to B bar, then A dot B will be equals to 0. So C will be equals to 0. That means when the two vectors are perpendicular to each other, the component of one vector in the direction of other vector will be equals to 0. So now what are the conclusions from this? The conclusions are the component of a vector B along A is A bar dot B bar by A bar dot A bar in A bar. Okay, because this is a scalar and this is a vector. And one more thing is, A bar is perpendicular to B bar, then component of one vector in the direction of other vector will be equals to 0. Now we will apply the same analogy for the signals. Now we are moving into the signals. So I have two signals, x of t and y of t. So these two signals are non-zero in the interval t belongs to t1 to t2. Now I want to represent y of t in terms of x of t in the interval of t belongs to t1 to t2. So y of t will be equals to c into x of t. This is a component of y of t in the direction of x of t, plus e of t, where e of t is the error associated with the representation. Okay. Now from the previous equation I can find the value of e of t. E of t equals to y of t minus c into x of t. Now my aim is to find the value of c in such a way that to minimize the error e of t. But e of t is also varying with respect to that time, so it is very difficult to do the minimization with the two variables. Now what we are doing is we are finding the mean square value of e of t. So mean square value of e of t is denoted by capital E is equals to integral t1 to t2 e square of t dt divided by t2 minus t1. This is the mean square value of e of t. Okay. Now we'll substitute this into the, we will substitute the value of y of t, sorry, e of t into this equation. So e equals to 1 by t2 minus t1 integral t1 to t2 y of t minus c into x of t whole square dt. So to find the value of the C which will minimize this error, so we have to do dE by dC should be equals to 0. Then only we can find the value of C which will minimize E. Okay. So now let's do the derivative for E. So now what I'm doing the derivative to the only this part d by dc integral t1 to t2 y of t minus c into x of t whole square dt. So so this will be equals 2 into y of t minus c into x of t plus y of t will be constant, then the derivative of minus c into x of t will be equals to minus x of t. So we should make this equals to 0. Now integral t1 to t2 2 into x of t y of t minus c into x of t will be equals to 0. Just I have expanded this. So from this the value of c will be equals to integral x of t y of t by integral x of t into x of t, that is nothing but x square of t. Just I am not writing the limits here. Okay. So now I have found the value of c. Okay. So the component of r y of t will be equals to c into x of t plus error, where c will be equals to integral x of t y of t by integral x square of t dt. In the case of vectors, we have seen that if two vectors are perpendicular to each other, then the c is equals to 0. Now let us assume x of t is perpendicular to y of t, then c will be equals to 0. So if you see here, there are two factors. One is integral x of t and y of t, and one more is integral x square of t dt. This is finite value, so it cannot be 0 or infinity. So the only remaining thing is 0, this one. So this has to be 0. So if c equals 0, then integral x of t and y of t will be equals to 0. So from this we have understood that if x of t and y of t are perpendicular to each other, then this integration will be equals to 0. Okay. So till now what we have discussed is we have represented a signal y of t in terms of x of t, but still we don't know this error. Okay. So before going to find this error, what we will do is we will generalize the equations what we have derived to an n-dimensional system. So till now we have studied how to represent a vector in terms of other vector and how to represent a signal in terms of other vector. Sorry, in terms of other signal. Okay. So the example what we have seen in the case of vectors is a two-dimensional example. So we have seen only 2D coordinate system. Okay. Suppose if the vector is three-dimensional vector, then how to represent this? How to represent that vector? Then we have to take three-dimensional coordinate system, okay, where x, y, z are the axes, and if you want to represent the vector a 2, 3, 4. Okay. Let's Vx is the unit vector in the x direction and Vy is the unit vector in the y direction and Vz is the unit vector in the z direction. Then A will be equals to 2A into Va 2Vx plus 3Vy plus 4Vz. Okay. This is uh, representation of this vector in three-dimensional coordinate system. If you see that Vx and Vy, Vz, so all three are orthogonal to each other. So Vx is orthogonal to Vy and Vy is orthogonal to Vz and Vz is orthogonal to Vx. So by using these three vectors, any three-dimensional vector can be represented. To represent any, so by using these three vectors, any three-dimensional vector can be represented. Okay, that's why this is called, So that's why this is called orthogonal vector space. Orthogonal vector space. So orthogonal vector space is nothing but a complete set of orthogonal vector which will able to represent any vector in that dimensions. So if you take three-dimensional coordinate system, then we can represent any vector using Vx and Vy and Vz. If you take two-dimensional coordinate system, we can represent anything using Vx and Vy. So similarly, if you have n-dimensional coordinate system, then we need n vectors to form orthogonal space. Okay, so v1, v2, so on vn are n orthogonal vectors that can form a orthogonal space. Now, any n-dimensional vector can be represented by using this set of vectors v1, v2, vn. So now you understood what is a orthogonal vector space. Orthogonal vector space is nothing but a set of vectors which can able to represent any vector in that dimensions. Okay. So now we are moving to orthogonal signal space. Suppose x1 of t and x2 of t, so on xn of t are orthogonal to each other. Okay, then the space formed by these signals is called orthogonal signal space. Orthogonal signal space. So in case of in case of vectors, if you have n vectors, then we can represent n-dimensional vector using these n vectors. It's not the case with signals. We have signal y of t, which we want to represent in terms of this set of orthogonal vectors xi of t, but we don't know this dimension of vector. So the representation of y of t will be something like this. Y of t will be equal to sigma ai xi plus some error function e of t, because we don't know the dimension of this y of t. So we are expressing this y of t in terms of all n signals which are orthogonal to each other, plus if there anything else is remaining, this will be represented by e of t. Okay, so now we will develop the same analogy what we have developed for two-dimensional case, or in the case of two vectors. This will be equal to ci. So now our aim is to find the value of ci in such a way that to minimize the error function e of t. So we have to use the same concept. Okay, if we solve similarly like that, we will get the value of ci will be equals to integral xi yi by integral xi of t whole square. We will get the same kind of equation for a dimensional case also. So this you can find in any of the book. It is very similar to what we have derived for the two signals. Okay, now what we have to discuss is we have to find the error function, or we have to find the error function e of t, or mean square error what we have seen previously. So the mean square error is e of t is equals to 1 by t2 minus t1 integral t1 to t2 y of t minus ci into xi summation I equals to 1 to n, okay, whole square. So when we expand this, what are the terms we will get? 1 by t2 minus t1 integral t1 to t2 will get y square of t, okay, plus we'll get ci square xi square of t. This will be summation I equals to 1 to n. All terms, cross product terms, like something like, then we'll have sigma I equals to 1 to n ci xi cj xj. But all these cross product terms will goes to 0, because xi dot xj will be equals to 0, because these two signals are orthogonal to each other. Okay, then we'll get also one more kind of summation I equals to 1 to n y of t ci xi of t. So we'll get these terms. Okay. So we have seen that ci will be equals to integral xi. Just I am omitting t to write to a simplicity. Okay, by integral xi square. So this implies integral xi of t y of t will be equals to ci into integral xi square of t. So we will substitute this in the equation. E mean square equals to 1 by t2 minus t1 integral y square of t dt minus integral ci xi square not minus plus ci square xi square of dt summation I equals to 1 to n minus 2 into integral y of t x of t xi of t ci, and this summation also I equals to 1 to n. So we can substitute instead of y of t xi of t, we can substitute ci into xi square t. Okay, so 1 by t2 minus t1 integral y square of t dt plus summation I equals to 1 to n integral ci xi square minus, when we substitute in summation I equals to 1 to n integral 2 into y of t. So instead of this we are substituting 2 into ci into xi square of t into ci. So this will be equals to 1 by t2 minus t1 integral y square of t dt minus ci square summation I equals to 1 to n xi square of t dt. Okay, so then now mean square error E mean square equals to 1 by t2 minus t1 integral y square of t dt minus integral 1 by t2 minus t1 ci square xi square of t dt.